Okay, so as I mentioned, we're going to be looking at the last 5 questions, the implicit differentiation questions. So number 10 is a chain rule. Number 11, we start with implicit. And as I said, I think we already did number 14 in class, so we'll skip that one. So we'll do the other 4. So for number 11, we have x to the 4th plus y cubed equals 5. So we're thinking of y as an implicit function of x, and we're differentiating both sides. So whenever you take the derivative of y, take the derivative as usual, and then multiply by a y prime. So the derivative of x to the 4th is 4x cubed. The derivative of y cubed is 3y squared times y prime, because it's implicit differentiation, and the derivative of 5 is 0. Then you just need to solve for y prime. So we're going to subtract 4x cubed on both sides. So we have 3y squared y prime equals minus 4x cubed, and then divide by 3y squared, and we are all finished. So we have y prime is minus 4x cubed over 3y squared. And that should be all you need. Number 11 here, minus 4x cubed over 3y squared. Go ahead and check that. So all set on number 11. Let's go ahead and move on to number 12. Won't be much different, I don't think. No factoring or anything difficult, just some basic derivatives. They don't start getting interesting until number 13. So differentiate both sides. Again, the right-hand side is just going to be 0 because the derivative of a constant on its own is 0. So the left will have 2x minus 2y times y prime, and that'll equal 0. So you could add 2y prime, and you get 2x equals 2y prime. And then 2y times y prime. I forgot to write down y. The derivative of y squared should be y prime. Or derivative of y squared should be 2y y prime. So 2y y prime equals 0. So then on the right we have 2y times y prime, and we just divide on both sides by 2y. So the left, the 2's will cancel, and we'll just get x over y is y prime, and that'll be our answer. So just x divided by y. So all set for number 12. Number 13 is a little more interesting because we have some chain rules going on. Not chain rules, product rules. X squared y and xy squared are both going to be 2 product rules. So x squared y plus xy squared equals 3x. So again, we're going to differentiate both sides. And we have 2 product rules to do. Remember, the product rule is the derivative of the first times the second plus the first times the derivative of the second. So for the first product rule, you're going to think of u as x squared and v as y. So the first product rule, we would have 2x times y plus the derivative of y, which is y prime, times x squared. So we get x squared y prime. Then we have a second product rule, the derivative of x, which is 1 times y squared. So we get y squared plus x times the derivative of y squared, which is 2y y prime. So we get 2xy y prime. And then the right-hand side, the derivative of 3x is just 3. So we're going to want to subtract the 2xy and also subtract the y squared to move that to the other side. So that only our y prime terms are on the left, which is going to allow us to factor. So we've got x squared y prime plus 2xy y prime, and that'll be 3 minus 2xy minus y squared. Now we can factor on the right. So we can factor out the y prime, and we'll get x squared plus 2xy times y prime, and this will be 3 minus 2xy minus y squared. And then we just divide, and we get y prime on its own. So it's this big mess, but it's the typical kind of pattern. You just have a bunch of product rules and then factor out the y prime that's left over, and then we get some big rational derivative in two variables. So 3 minus 2xy minus y squared, all being divided by x squared plus 2xy. So let's be careful and make sure we enter that properly. So 3 minus 2xy minus y squared by x squared plus 2xy. Make sure it came out correctly. So number 13. Yep, got it right. As I mentioned, number 14. Number 14, we did something very similar last class, so I would encourage you to look at the notes from last time. If we look, it was, what did we call it? 3.5 implicits at the very end. We did one similar, so this was the one of the examples, x squared plus xy plus y cubed. So the example we did at the end of last time, almost identical, except we were plus y cubed and at 1, 1. The problem that they have you doing is x squared plus xy plus y squared equals 3. So it's completely identical except for that. So for number 14, you can follow that problem from the notes last time. But notice that they have y squared, not y cubed. But everything else is going to work out the same. So let's just do number 15, the asteroid problem. So number 15, we want to use implicit differentiation to find the equation of the tangent line at the point. So we have x to the 2/3 plus y to the 2/3 equals 4, and we want to do it at minus 3 root 3, comma 1. So again, we got to find the derivative, same as before. So if you differentiate both sides, again, we're just using the power rule. We've just got some fractions. So we get 2/3 x to the minus 1/3 plus 2/3 y to the minus 1/3 times a y prime, and that'll equal 0. So we just want to solve for y prime. Let's go ahead and just multiply everybody by 3. So if we multiply both sides by 3, we'll get 2x to the negative 1/3 plus 2y to the minus 1/3 y prime. That'll equal 0. We'll subtract the minus 2x to the negative 1/3. So we have 2y to the negative 1/3 y prime equals 2x to the minus 1/3. And then divide by 2y to the 1/3, negative 1/3. So we have y prime. The 2's cancel. We get x to the negative 1/3 over y to the negative 1/3, which is actually the same thing as y to the 1/3 over x to the 1/3, or if you prefer, the cube root of y over the cube root of x. However you prefer, but we want to find the tangent line at this point, negative 3 root 3, comma 1. So the first thing we want to do is find the slope. Our slope, we plug in the points. So we plug in 1 for y. It's going to be the cube root of 1 over the cube root of negative 3 root 3. So quite the complicated slope here. 1 over does that simplify in any meaningful way? I don't know. So we can write it as negative cube root of 3 radical 3. And you could put the squared inside, so this would be -1 over the cube root of the square root of 3 to the third. So the cube root of 3 to the third is 3. So I think we just have -1 over the square root of 3 as our slope. Or if you want, you could write it as radical 3 over 3. Again, if you're not great with radicals, that might seem confusing, but so now we just want to put it in the tangent line form. So we've got y minus 1 equals this negative root 3 over 3 times x minus negative 3 root 3, which is going to be plus x plus 3 root 3. So, I mean, you can multiply through if you want. So negative root 3 over 3x. And then we're going to get minus, the 3's will cancel, and then the radical 3's will actually make that square root of 3 times square root of 3. So it's just going to be minus 3. And then you can add 1 to both sides. So you get y equals minus square root of 3 over 3 x minus 2. So maybe somehow I've done all the arithmetic properly and this actually comes out as the answer. We'll see. Yeah, fairly complicated stuff with the radicals though. Maybe I can go back over that in a second. Definitely much more difficult than I remember. If that works. No, it looks like I already marked it wrong. But I'll make this from before. Didn't check the new answer. Okay, so maybe I did something wrong with the arithmetic. It's marking it wrong. 3 root 3x minus 2 equals 4 over here. That shouldn't have anything to do with it. Okay, so let's have one quick look to see if we messed something up. Clearly we did. So I don't see anything wrong with the derivative. Three root 3 comma 1. Let's make sure that's the right point. Minus 3 root 3 comma 1. Okay, that's the right point. So the cube root of 1 over the cube root of 3 root 3. Is that right? So that's x, certainly. Now, the one thing I was doing for the simplification was I was basically saying 3 radical 3 is the same thing as 3 is the square root of 3 squared times the square root of 3, which is what's making that the square root of 3 to the third power. So then I said, well, if you take the cube root of that, you could just take the cube root of 3 to the third, which is 3, right? So the cube root of the square root of 3 cubed is the same thing as the square root of the cube root of 3 to the third, which should be the square root of 3. And you can always pull the negative out in front of a cube root. So that looks correct to me. And then here I'm just multiplying by square root of 3 over 3. So this looks fine too. So that's my slope. So y minus my y coordinate, which is 1, y minus 1, is equal to my slope, negative square root of 3 over 3, times x minus my x coordinate, which is x minus 3 radical 3. So then I'm trying to multiply through. I multiply through. So negative 3 root 3 times x. Then my 3's cancel, and I get minus square root of 3 times square root of 3, which is minus square root of 3, minus, minus. Did I do minus, minus? Yeah, I did minus, minus. to this point. Let's see if the graph is horribly wrong. If the graph is horribly wrong, then that's further evidence that we did something bad. So our equation, this asteroid equation, is x to the 2/3 plus y to the 2/3. Asteroid. And then we said we were doing y equals negative / square root of 3 over 3x minus 2. Yeah, so definitely something is wrong. We're supposed to be tangent at this little dot here, which means our slope, we would expect that to be a positive value. So why is our slope turning out negative? That's a question. Why is our slope negative? Our slope should be positive. So this over this, we have a negative x value, positive y value. Now you could have a negative if you were down here, but we're at a positive y coordinate. So why is that happening? Our slope should clearly be positive here from the graph. So what mistake are we making? So we've got this, we did the derivative. I believe we did it right. You just bring the exponent down and subtract 1. There's the mistake. So notice that when I subtract, I should be getting a negative here. So I subtract 2x to the 1/3, I should be getting a negative sign here. So I should be getting a negative here. So my slope should be negative. So I dropped a negative. So my slope, in fact, should be positive. That negative sign should not be there. I should have another negative in front, which will make this a positive. Okay, so the slope should just be positive. That would make this positive, which would make this plus the square root of 3. Well, it would make this positive. So the slope would be positive here. Then when I multiply through, I would get plus the square root of plus 3. So then when I add, I should get a plus 4, not a plus 2. Let's look at the graph and make sure that that makes sense. But I suspect that's it, just dropping a negative. So it can happen to anyone. You see now we're tangent right at that point that we saw in the graph. So let's move back to the assignment just to double check. So this negative is gone. And we have a positive there. So a lot of times if the graph doesn't make any sense like that, the slope was completely wrong. That's what, really pointed out that I was going to have a problem, just dropping a negative somewhere. And I did plus 2, plus 4. I forgot to change that. I just changed the signs. I forgot to change to plus 4. Okay, there we have it. Now we've finally gotten it right. Just a stubborn little negative sign, but everything makes sense now. So that should be it on this. I think you should have, the implicit one should go okay. This number 15 was definitely challenging, but hopefully you were able to follow that. I'll try and get this video posted. Like I said, it normally takes like an hour for WebEx to make it available, and then I can post it after that. So let me go ahead and stop the recording.